In today's lesson, we are going to be looking at Z-scores, percentiles, and probabilities. So just as a quick review, in our previous lesson, we looked at the rule of 68, 95, 97, or 68, 95, and 99.7. So this was again talking to us about how we can use those numbers to find the probability or percent of data points that are within given intervals. Because the idea of 68% of the data falls within one standard deviation, 95% of the data falls within two standard deviations, and then finally 99.7% of the data falls within three standard deviations. So by using those different groupings and looking at each individual kind of portion of our normal distribution, we could find the probability of it falling within certain values, but each value had to be restricted to something that was a certain standard deviation away, right? Whether it was 1, 2, 3, 4, or 1, 2, or 3 standard deviations plus or minus from the mean, those were the values that we were looking at. But when we're trying to look for the probability of data falling between certain values or greater than or less than values, it's not always going to fall on those that are exactly 1 or 2 or 3 standard deviations away. So we need to look at or come up with a way to find the probability for values that don't fall nicely on the standard deviations. And that's where Z-scores come into play. So Z-scores by definition are a measure of the number of standard deviations a given data point is above or below the mean. Right? So the Z-score is basically just another way of saying this number of standard deviations away from the mean a data point is. So for example, hurricanes with an average speed of 257 kilometers per hour and a standard deviation of 16 kilometers per hour have values of 209, 225, 241, 257, 273, 289, and 305, those would have Z-scores of -3, -2, -1, 0, 1, 2, and 3 respectively. So what do we mean by that? What does all that mean? Well, if we were to look or draw our normal distribution, if I could draw a nice one, right, so right down the middle, we have our mean or average, which is 257. Then, one standard deviation above, we have 273, and below we have 241. Two standard deviations away, we have 289. Two standard deviations below, we have 225. And then three standard deviations away, we have 305 and 209. So that would be what our kind of normal distribution would look like. Down a bit, and these would have, again, no standard deviations away because it's our average. 1, 2, 3, -1, -2, -3 standard deviations away. We could say plus if we wanted to. Now, instead of doing that or talking about those standard deviations, we could refer to it as Z-scores. So in the middle, we have a Z-score of 0. So these are, let's say these are standard deviations. Then the next, we have our Z-scores. So our Z-scores would be again 0 for the middle. Then we would have a Z-score of 1 or -1 for one standard deviation plus or minus. We would have 2 or -2. And finally, we'd have 3 or -3. So it's the same thing as labeling with standard deviations. Now we're just referring to them as Z-scores. So to calculate Z-scores, there are two different formulas that we could use. Again, depending on what we're looking at, you might recognize some of these symbols. Right? We have mu for the mean. We have x bar for the mean as well. Theta for standard deviation. S for sample standard deviation. So essentially, these are just two different versions. One if we're looking at the population, and the other if we're looking at a sample. Formula stays, like essentially the process is still the same, It's just changing of the variables depending on what we're looking at. So to find the z-score, you take a specific value from a normally distributed random variable, you subtract the mean from it, and then you divide it by the standard deviation. So again, regardless of whether you're looking at a sample or a population, that is what you're going to be doing. The data point or the value minus the mean divided by standard deviation will give us our z-score. So, for example, let's go through and just practice calculating a few z-scores. Again, we want to make sure that we know what our average is or our mean, and that we know what our standard deviation is. We do need to know that when we're going through and calculating the z-scores. It does help if the question mentions that it's approximately normally distributed, so we know that it kind of fits that kind of pattern or trend. So for z-score, find the z-score for an x value or a wind speed of 230. In this case, our z-score is going to be 230. Our data point, or the formula, x minus, we'll say we're looking at population, so mu divided by the standard deviation. So we have 230 minus the mean, which is 257, divided by the standard deviation, which is 16, and we get a z-score of negative 1.69. So that means that the value of 230 is 1.69 standard deviations below the mean. For B, same idea. Z-score equals x minus mu divided by standard deviation. We have 280 minus 257, which is our average, divided by 16, and we get 1.44 of z-score. So that means that a value or a wind speed of 280 kilometers per hour is 1.44 standard deviations away from the mean. C is now saying, okay, what is the speed for a z-score of negative 2.3? So here we're just working backwards. We still have the same formula, z equals x minus the mean divided by standard deviation, except now in this case, we know the z-score is negative 2.3. We don't know x. We do know the mean is 257, and we're dividing by 16. So here we're going to rearrange our formula. I'll bring it up over here just for the space. So we're going to bring the 16 up to the other side. So 16 times negative 2.3 is negative 36.8 equals x minus 2, should be 257. And now we're going to add the 257 to both sides, or to the one side. So negative 36.8 plus 257 gives us 220.2, which is our wind speed. So that means a wind speed of 220.2 kilometers per hour is 2.3 standard deviations below the mean. So how does this all work? How does this help us find probabilities of values? Well, with the z-scores, right, we can determine the percentile for a given point. Right? Again, a percentile is the percentage of data that is below a given value. Right? So essentially what we can do is we can use these z-scores to find or give us a percentile, which would then tell us the probability of values being below. Right? So we can determine the percentile from the z-scores. Percentile is the percentage of data that is below a given value. And what we're going to be using is we're going to use a chart to basically give us the percentile for a z-score. So we will have these charts. Right? And essentially, they're basically called ZScore tables. They basically give us all the different percentiles for all the possible z-score values from, it looks like, negative 3.4, so 3.4 standard deviations below the mean, all the way up to, I believe, about 3.4 on the positive end as well, or 3.49, sorry, and negative 3.49. So the way this works is we see our z-score and we see we have the ones and the tenths on the left, right? So we can see here is we have negative 3.4, negative 3.3, and so on. And along the top, we have the hundredth position of our value. So you would read it as if I was looking for, say, negative 3.35. So when you're finding the z-scores, you're always going to round to 2 decimal places. I would go over to negative 3.3, and I would go over to 0.05. So that would be combined negative 3.35, and kind of like a multiplication table, find the value that corresponds. So that means that of a z-score of negative 3.35, the percent of data that is below is 0.0004 is my probability of a value being below whatever data point I'm looking at. The key thing is for this, right? When you're looking at the z-score tables, these values, these percentages, they're always for below, equal to, or below the value that we're looking at. Whether we're looking on the negative side or on the other side of our table, which is going to be the positive side, right? So above the mean, every time we find the value, it's always going to tell us the probability of a data point being equal to or less than whatever value we're looking for. Right? So the z-scores are always telling us the percentage below a data point. Right? So if these are my data points, we're always looking below the data point, or less than, you could argue. So let's practice using our z-score table or z-score chart to basically see if we can find the certain values. So if we had a z-score of 0.82, what percent, or find what percent is below that number? Right, so we don't know what the number is, but we do know that the percent, we do know what the z-score is. So we don't know the specific value, but we know what the z-score is. So what we're going to do is we're going to go to our z-score table. So our z-score table we can see here, and we're going to try to find the z-score of 0.82. This is our z-score that we're looking for. So we go over to our table. The first part, or the first half, is our negative up to 0. And then we're going to go above, so the second part, and we're going to look for 0.82. So we can see two things. Let's highlight a bit here. I can see the 0.8, which is one part that I'm looking for. And in the hundredth column, 0.02. So I'm going to go to the middle and find kind of where they meet. So 0.82 brings us down here. Zoom in a bit. So we can see this is our percentile. So this is the percent of data that is below whatever value gave us that z-score. Now again, these are all in decimals. So 0.7939. Or 79.39% of data is below that value. Now, what z-score is at the 82nd percentile? So here is going to be a little bit different. Here, what we're going to do is we're going to look on the inside. We're going to look at everything inside the table. Right? So we're not looking at on the outsides. We're looking on the inside, and we're going to find the 82nd percentile. So we're going to go scroll through and see where we can find 82. So here I can see 0.8212, 0.8238. So that's a little bit above, so I'm not going to worry about that one. So if I go below, I'm at 0.8186. So basically you're going to try to find whichever one is closest to that percentile. So in this case, the closest one would be the 0.8212. So that means what is the z-score at a percentile of 82, or the 82nd percentile? So we found that percentile in our table. Now we're going to the outside to find what two values for our z-score. Kind of, you could like hypothetically, or kind of multiply to that middle value, even though we're not multiplying. and we get a z-score of 0.92. So a value that is 0.92 standard deviations above the mean will have 82% of the data equal to or less than. Now we're going to look for what is the percent of data, or what percent of the data is above a z-score of 9 or 0.91. So I'm already close to that. I'm just going to erase these two. I already have the 0.9. I just need the 1 now. We get that we have a percentile of 81 or 0.816 or 8186. Now the key thing here though is that we're asking for the data that is above that z-score. And all of the z-scores give the data that is below. Right? So realistically, if I'm looking at my normal distribution here, we're looking for a z-score of 0.91, so it's above the mean, so above that hump. The value that we found from our z-score, that 0.8186, that is everything below that z-score. So how do I find everything that's above? Well, if I want everything above, I have to use kind of the indirect method. The entire probability is equal to 0. So if I want just this section here, then I would do 1 minus that z-score. So 1 minus that z-score gives us 0.1814. So that is the probability that is above that z-score. So you might have to use the indirect method a little bit. D is asking what percent is between a z-score of 0.3 and 1.21. So this is going to be a little bit different because now we're looking between values. So if I want to look between values, I have to do something a little bit different. So I take my normal distribution. I'm looking for 0.3, so that's above the mean slightly, so 0.3 standard deviations, and then 1.21, and I want to find everything in the middle here. That's what I'm looking for. I'm looking for what percent of data falls between those two values. What we're going to do though, because the z-score table doesn't give us the probability, let me just go back and we'll take a look at it. Because the z-score table doesn't give us values between, it only gives us less than, we have to do a little bit of basic math. So if I find the value of the z-score for 0.3, that is going to give me everything below. Don't worry about the z-scores in a second. If I find the percentile for the z-score of 1.21, that's going to give me everything below that, which includes some of the data for the value z-score of 0.3. So if I want just this section here, it looks like I'm just coloring a bunch of random colors, I have to take my percentile from the farthest one, the 1.21, subtract the percentile of the lower one, and the remainder will be the gap in between the two of them. So let's go through and take a look at our z-score table. So the first z-score we want to find is 0.3. So I'm just going to erase some of these. So 0.3, you see here, there are no decimals after that, so 0.30, and we get a z-score of, or a percentile of 0.6179. So if I look at my normal distribution, that means in green here, everything below this line, there is 0.6179, or 61.79% of the data. My other z-score of 1.21, so I go 1.2, and I'm going to go to 1 for my hundredth, so 1.21, and that is 0.8869. So So that means if I look at my normal distribution that everything below here is 0.8869. And if I just want to find this little gap here, I have to subtract. So what I'm going to do is 0.8869. I'm going to subtract the lower percentile, 0.6179. And that will give me the value of just in between them. We'll go back to it because we don't need the Z-score anymore, the table anymore. We will get 0.2690. So basically 26.9% of the data falls between Z-scores of 0.3 and 1.21. So we've looked at how we can use Z-scores to find the percent of data falling within a range or above or below certain values. So now we're going to do that where we actually have to calculate the Z-scores first, and then you go to the table. So determining the following for the speeds of hurricanes winds which are normally distributed with a mean of 257 and a standard deviation of 16. So same values that we've been looking at. The probability that a hurricane measures a speed of less than 230. So sometimes it helps to kind of draw it to visualize it. So we have our mean here. 230 is below that. And we're trying to find out this probability, less than 230. So we need to find a Z-score. So the value minus the mean divided by the standard deviation gives us negative 1.69. So that's our Z-score. So that value of 230 is 1.69 standard deviations below. We're now going to go to the table. And from there, we find that the probability that a value is less than, we can say or equal to, because in our previous lesson we talked about being equal to a value in continuous values is 0. So we're allowed to say less than or equal to is the same as less than. So 230 is then equal to 0.0455. So that value just comes right from the table. What is the probability that a hurricane measures a speed of greater than 270 kilometers per hour? Again, you might want to highlight or notice that we're talking about a speed of greater than, right? So I'm just going to draw our normal distribution. So 270, it's above the mean, so above the hump. And we're looking for greater than, so we're looking for above. Keep in mind, the Z-score table, remember, always gives us below or less than. So I do need to find my Z-score first. So 270 minus the mean of 257 divided by the standard deviation of 16 gives me 0.81. With that Z-score, I go to the table. And that will give me the percentile. But because I'm the table, what it will give me the probability of a value being less than or equal to 270, which in this case from the table we get is 0.7910. We need to do the indirect method. So if that's the probability of less than 270, then the probability of a value being greater than or equal to 270 is 1 minus 0.7910, which is 0.209 or 20.9% chance of a value or hurricane speed being above 270. C. Find the probability that a hurricane measures a speed of between 260 and 220 or 280. So similar to what we've done before in this lesson. Right, I'm just going to draw a normal distribution. 260 is above, and so is 280. So I'm looking for this area or this probability or percent of data within those two. So in this case, we're going to have to do some subtraction because we were looking for this interval. So I'm going to find the z-scores of each data point first. So 260 minus 257 divided by 16 gives me a z-score of 0.19. Our other z-score or other value, 280 minus 257 divided by 16 gives us a z-score of 1.44. So now we're going to go to the table. Go to table. And for each one, we end up with 0.5753. So 57.53% of the data is below 260 and 0.9251. So 92.51% of the data is below 280. So to figure out the gap, I need to subtract the higher z-score percentile from the lower one. So the probability that a value is greater than 260, less than 280 is equal to 0.9251 minus 0.5753, which gives us a probability or percentage of 0.3498. So 34.98% of the data is going to fall between those two values. Now, again, likewise, what we're going to be doing is we can also go from a percentile back to a value. So what would be the speed of a hurricane that has a higher speed than 90% of the other hurricanes? So we are looking for 90%. So in this case, we are looking for basically the 90th percentile, right? If it's higher than 90, or what would be the speed of a hurricane that's higher than 90%, basically we're finding that 90th percentile. So what we need to do now is we need to go to the table. So we need to go to the table and look on the inside for 0.9000 or as close to that as we can, because that would be 90%. When we go to there, we find that the closest value we get is a z-score of 1.28. So now with that z-score, now we can go back and find what that data value is. So we have x equals x minus the mean divided by the standard deviation. 1.28 equals x minus 257 divided by 16, and very similar to previous question that we've done before. We can multiply 1.28 by 16, 20.48, and then we're going to add the 257 to it, and we end up with a value of 277.48 equals x. So that means that a wind speed of 277.48 is higher than basically 90% of the other hurricanes, or it's all 90% of other hurricanes are either less than or equal to that. What would be the speed of a hurricane slower than 75% of other hurricanes? Right, so a little bit different in the wording. If we're looking for a hurricane that is slower than 75%, right? So if we're looking slower than 75, that means wherever the mark is, everything above is 75%, and everything below is 25%. Now keep in mind, whenever we look for the probability or when we find a percentile in the table, it tells us less than. So that means we're looking at finding the 20th percentile or 25th percentile. Go to the table. looking for a value of 0.02500, somewhere in the middle, and trying to find the z-score attached to it, which in our case we should find close to negative 0.67. And again, if you have trouble reading the z-score table, just go back to the previous questions where we looked at using the z table specifically. I'm just saving from jumping back and forth just for time. We get that from the table. Now again, same idea as the previous question. We're going to plug that back into our formula. So negative 0.67 equals x minus 257 times 16. Bring the 16 up and multiply, we get negative 10.72 equals x minus 257. Add 257 to both sides, and we get 246.28 equals x. So that means that a speed of 246.28 kilometers per hour is slower than 75% of other hurricanes, but also greater than or equal to basically 25% of the speeds. So the main thing in this lesson is understanding that we can't use the 68, 95, 99.7 rule. We do have to come up with a different method for finding the percentage of data that can fall above or below or between values in a approximately normal distributed data set, because not everything falls 1, 2, or 3 standard deviations away from the mean. So in order to do that, we need to define z-scores, use our z-score table to find percentiles. And again, similar to the 68, 95, 99.7 rule, there are various scenarios of finding greater than or less than or between, which requires us to either subtract or use the indirect method when working with those percentiles. But again, the main thing is just a different method or kind of a continuation on what we did to look at more complex scenarios.